The Teverun Fighter Mini Pro is widely regarded as one of the best electric scooters on the market. It strikes a rare, near-perfect balance of performance, portability, and premium design. Enter its new budget challenger, the Teverun Fighter Mini Eco. Side by side, it is nearly indistinguishable from the Pro. It retains the exact same carbon fiber styling, the tight cable wrapping, and those whisper-quiet Bosch motors. The consumer appeal is obvious. The Eco promises roughly 90% of the Pro's premium features, but at a significantly reduced price point. But there is a catch. During our initial testing, the first Eco unit suffered a catastrophic thermal shutdown mid-ride. The failure sequence was rapid. The scooter threw an E6 overheat warning, forcibly throttled its own speed to protect the battery, and moments later completely died on the side of the road with an E3 error. Teverun quickly sent out a second replacement unit. To see if that initial failure was an isolated fluke or a symptom of a deeply compromised machine, we subjected the new unit to a grueling high-temperature gauntlet. This stress test will determine if cutting corners on a budget model ultimately breaks the reliability required for high-performance electric vehicle architecture. The testing grounds were set on a 90-degree Fahrenheit day. This heat was intentionally chosen to push the scooter's thermal limits as far as they could go. On the surface, the Eco holds up well. A 0 to 30 miles per hour acceleration test clocked in at a brisk 7.8 seconds, proving this budget model has not lost its initial punch. We also verified its top speed. Pushing it with a tailwind, GPS tracking confirmed a maximum speed of exactly 36 miles per hour. Hitting those speeds reveals the first set of compromises. The Eco trades the premium hydraulic suspension of the Pro for standard spring suspension, resulting in a noticeably bouncier ride when pushing 36 miles per hour over uneven pavement. The cockpit sees a few downgrades as well, like a swap to a basic LCD screen and some slightly loose plastic clamps on the controls. These are reasonable, acceptable compromises for a budget model. While these surface-level mechanical changes are noticeable, they don't impede the scooter's functionality. The true danger of the Eco lies entirely hidden beneath the deck. Moving from short speed bursts to a sustained 16.7-mile maximum range test changes the equation entirely. Sustained riding is where the real thermal threat begins to take hold. The issue comes down to a core engineering mismatch. The entire architecture of the Fighter Mini was designed around a highly efficient 60-volt Samsung battery. For the Eco, that power source was downgraded to a generic 52-volt system. This diagram shows exactly what happens when you drop the voltage. To maintain that 36 mile per hour top speed with a 52-volt battery, the electrical system is forced to draw significantly more current to achieve the exact same wheel speed. Pushing all that excess current has a direct byproduct, heat. It rapidly generates extreme temperatures inside the tightly confined battery compartment and within the motors themselves. This creates an immediate problem with thermal inefficiency. As these electrical components heat up, their physical electrical resistance increases, making it harder for the energy to flow. This triggers a dangerous feedback loop. The increased resistance forces the battery to pull even more current just to sustain the same speed, which in turn generates even more heat. This is an exponential physics problem. The hotter the scooter gets, the harder it has to work, rapidly accelerating its own internal failure. To put this feedback loop to the ultimate test, we pointed the Eco toward a steep, sun-baked incline, a hill notorious for killing electric scooters. Going up the hill, the tension mounts. You constantly watch the display for that dreaded E6 shutdown code, while the machine strains to maintain 25 miles per hour against the steep grade. This second unit survived a 10-mile ride without shutting down, but the post-ride diagnostic data was alarming. The motors reached a blisteringly hot 51 degrees Celsius, and the deck itself was hot to the touch. There is a practical workaround for consumers willing to compromise. You can use the mobile app to detune the scooter, capping its top speed at a safe 28 miles per hour. But artificially limiting the performance to the speeds of a standard Class 3 e-bike entirely defeats the purpose of buying a 36 mile per hour performance machine in the first place. The 52-volt downgrade leaves the Eco constantly operating on the razor's edge of thermal failure whenever it is pushed to its advertised limits. True value in electric vehicles requires holistic engineering harmony. To guarantee the thermal safety and longevity of your machine, spending the extra money on the Premium Mini Pro is the only logical choice.